This lesson is going to regard quadratic equations, and to begin with we need to learn how to solve just simple quadratic equations, especially if there's just two terms. If we have the problem x squared equals to 49, then if we take the square root of both sides, we would be left with x, because the square root and square cancel each other out, and the square root of 49 is 7, because we know that 7 times 7 is 49. But also, negative 7 times negative 7 is 49, so when we take the square root of a number by itself, we need to put plus or minus in front. Now, as far as entering this in for homework, you probably have to enter a positive 7 and then a negative 7 separated by a comma. In this next example, we need to have our square term by itself, so that means we're going to add 11 to both sides, so we would have x squared equals to positive 11. Then take the square root of both sides, putting your plus or minus right there because it is both positive and a negative, we'd be left with x equals to plus or minus the square root of 11, and we don't know the square root of 11 because it's a prime number. In the next example, we can go ahead and take the square root of 20, and that would give us y equals to, we have our plus or minus, we'd have plus or minus, but we need to break 20 down because 20 is not a prime number. 20 does divide by the prime number 2 10 times, and 2 divides into 10 5 times, so we have a pair of 2's because it's a square root, we're looking for a pair, so that gives us 2 square roots of 5. And again, our answer is actually positive 2 square root of 5 and negative square root of negative 2 square roots of 5. So in this next case, we need to have our square term by itself, so we can divide both sides by 2 to begin with, and we would have x squared equals to positive 2. And then we would take the square root of both sides, and we put plus or minus prior to the radical. So we would have x equals to plus or minus the square root of 2. Again, for course compass, we would enter it in square root of 2 and negative square root of 2. In this next case, we don't have a way of getting our variable by itself, so we have to look at the y minus 3 squared as a whole, so we can still take the square root of both sides. This is a number by itself, so that's why this side receives the plus or minus mark, but this side does not because it has a variable also on the side, the left-hand side. So we're left with y minus 3 equals to plus or minus. We know that the square root of 4 is 2, and once we take the square root, we're finished with the radical, using the radical. So we need to add 3 to both sides because we need to solve for y, the variable. So this negative 3 becomes a positive 3 when we add it to the right-hand side, so we still have plus or minus 2. We can actually add and subtract this, so we have y equals to 3 plus 2, which is 5, and 3 minus 2, which is positive 1, and still having two answers. In this next case, to be able to get our square term by itself, first thing we need to do is move the 36 to the left-hand side, so that makes it negative 36. Divide both sides by 3, and we would have p squared is equal to negative 12. Well, when we take the square root of both sides, even though that 12 is negative, we still have to place the plus or minus in front of the radical. So we're left with p equals to plus or minus. Now remember, the square root of a negative number is I, and we also need to see if 12 breaks down into prime numbers. 12 does divide by 2 6 times, 2 divides into 6 3 times, so we do have a pair of 2's. So our final answer is going to be positive 2 square roots of 3i and a negative 2 square roots of 3i, and of course that I being exterior of the radical. Now, as far as solving more complex quadratic equations, we have 5 steps that we're going to follow. The first one is completing the square process. The first one is isolating the x terms, or whatever the variable is, on one side of the equation. The second one is to divide by x squares, y squares, or whatever your variable squares coefficient is. Then we're going to multiply by the variable, just the variable, not the square terms, coefficient. We're going to multiply that by 1/2. We're going to square it, and we're going to add it to both sides. The fourth step is we're going to write the left-hand side as a perfect square. I'm going to show you how to do that. And then the last thing we're going to do is we're going to solve for that variable. And again, I just used the variable x, but these can be y's or z's or whatever the variables might be. So let's look at a problem using this 5-step process of completing the square. And in this case right here, step 1, we would place our x's on one side. That means our constant term has to be on the other side. So we have 3x squared minus 4x equals to positive 4. Now we always want our highest term to be a positive. So if it's not positive, we need to change our signs. Or else when we take care of step 2, we divide by x squared's coefficient. In this case, it would be a positive 3 You divide each term individually, and then we simplify. That's the step that's not written in all of the 5 steps for completing the square. So when we do this, we're going to simplify and have x squared. We can't simplify negative 4/3, so we're going to leave it alone, equals to positive 4/3. I'm going to do a scratch work out here to the left. So I'm going to take x's coefficient, which is negative 4/3. I'm going to multiply it times 1/2, and I'm going to square it. Well, in this case, I can do a little bit of reducing here. 2 divides into 4 2 times. Now, notice I didn't cancel that negative sign out, so I'm left with a negative 2 in the numerator and a positive 3 in the denominator, and I still have to square it. So negative 2 times negative 2 is positive 4. 3 times 3 is positive 9. Now, this is the number that I add to both sides, here and here. And again, it's an equation. What you do to one side, you do to the other. We're on step 4 now. We're going to write the left-hand side as a perfect square. So you take the square root of the first term, which is x. Take the first sign always, and the square root of the number before the equal sign. So the square root of 4 is 2. The square root of 9 is 3. Now on this side, we can go through here and get a common denominator. The common denominator for 3 and 9 is going to be 9. And what I put in my parentheses, what times 3 gives me 9, which would be 3. What times 9 gives me 9, which is 1. So I'm going to have 4 times 3, which is 12. And then 12 plus 4 times 1, which is going to be 4, which is actually going to give me 16 ninths. And I'm just going to rewrite this. Haven't done anything to the left-hand side. So that's just adding fractions with a common denominator. All right, now we're back to where we were with the first page. We have to undo this square, so we're going to take the square root of both sides. We're going to put plus or minus here. This cancels, the square root and the square cancel, so you're left with x minus 2/3 equals to plus or minus the square root of 16 is 4. The square root of 9 is going to be 3. We've got to add 2/3 to both sides, so that negative 2/3 becomes a positive 2/3 plus or minus 4/3. Now, there are no radicals, there's no imaginary numbers. That means we can actually add and subtract these two numbers. Now, my denominator for both is going to be 3, so I would just go ahead and write that down, because really what you're adding and subtracting is the numerator. So 2 plus 4 gives you 6, 2 minus 4 gives you negative 2, and then I would simplify. 6 divided by 3 is 2, negative 2/3 is just negative 2/3, but those would be the two solutions to that.